I'm Dave. In this video I'm going to give a brief overview of measurement system analysis. But before I start, let me just set the scene. Why do we care? Well, I guess that most people who are watching this video are involved with running and controlling processes. And the way we get a view of the process is by using a measurement system. What this means is that we need to be aware that the measurement system could be distorting what we see. If it's a good measurement system, it'll give us very little distortion. But if it's a poor system, it's going to give us a very distorted view of our process. So, measurement system analysis has been developed as a set of techniques that can tell us how good or how bad the measurement system is. It basically tells us, for example, if I measure half an inch on this part, how much can I trust my measurement? So I think you'll agree that's pretty critical to controlling any process, so that sets the scene for why we need measurement system analysis. This is what I'll be talking about in this video, and by the end you should have an understanding of measurement error, bias, linearity, stability, repeatability and reproducibility in Gage R&R. I'm going to warn you that there's a fair amount of jargon involved in this subject, but by the end of the video we should have cut through most of it so that we understand the main concepts. Now, before we can get to any of those things, we have to understand measurement error, so let's take a look at that. Imagine that you take a single piece, a single part, a single object, and measure it 50 times and record the measurements. Now let's assume that the gauge that you use is not perfect, so if you took your 50 measurements and plotted them on a histogram, what would they look like? What I would expect to see is that most of the measurements would be clustered together, but there'd be a few that were a bit more extreme on the large size or on the small size. In fact, I wouldn't be too surprised if we ended up with a histogram that looked like this. So at this stage, I'm going to ask you to take a leap of faith with me, and I'm going to tell you that we can model this pattern of measurements using a normal distribution. You've probably seen the bell-shaped normal distribution curve before, and if you haven't, you should Google it and you'll find plenty of information about it. Most of the statistical techniques used in measurement system analysis are based on this, so it's really worth getting to know. Right, so the normal distribution models our measurement error, and we can use the fact that the normal distribution can be specified using two values. The mean, which is the center or location of the distribution, and the spread or width of the distribution, and mathematically we could call that spread the variance or standard deviation. So let me summarize where we're up to. We've got some idea of measurement error, we know it's normally distributed, and we know that we can define it by the mean and the standard deviation. But at this stage you may be asking yourself, where does the error part of measurement error come into it? Well, first let's look at the mean. If we imagine that we had taken a super accurate reference or standard of a known size, let's say 0.500, and if we took 50 measurements of this reference, we could draw the normal distribution curve and see if the mean of the distribution was also at 0.500. So take a look at this chart. The standard or reference that we measured was 0.500, but the mean of our measurements was 0.475. So on average, this gauge underestimates the size by 0.025. So what we would say is that this gauge has a negative bias of 0.025. If we look at a picture like this, then we have a positive bias. The gauge measures too big. Now I just want to make a side point here. It's actually a bit in this because in reality we have to take into account that the mean of the measurement error is an estimate based on a sample, and we have to account for sampling error. But don't worry about that at this stage, I'll cover that in a later video, because for now all we're trying to do is build a conceptual model of the whole topic of measurement system analysis so that we can see where everything fits together. And the next chart, this shows zero bias, which is obviously what we want. So at this point we know something about bias, but we've missed a couple of things about it. What are they? Well, the first thing is that we don't usually just use a gauge to measure one size. It has an operating range. It measures various sizes. The second thing is that we looked at bias at one point in time. But what if bias changes over time? For a mechanical gauge, we could imagine that the gauge mechanism could wear over time, which would affect the bias, or for an electronic gauge, we might expect some drift in the readings as time goes by. So let's go back to the first one, which is called linearity. And linearity is an assessment of the bias we get when we measure at different sizes across the operating range of the gauge. The second one is called stability, and it's an assessment of how bias changes over time. Now, for most standard gauges, the calibration system really helps us with these two things. The calibration procedure should involve measuring references across the operating range of the gauge, say at 3 or 5 points, so that covers linearity. And the next thing is that the calibration system ensures that the gauge is recalibrated after a certain time, based on the recall frequency, so that helps us cover stability. So, just to summarise where we're up to, we went over bias and we then did a quick review of a technique called a Gage R&R study that we can use to assess variation in a measurement system. And that's it. That's your overview of measurement system analysis. So feel free to use this video for your own training, and there's a full set of PowerPoint slides that you can use, that you can download from my website. And in fact, if you want to know more about Gage R&R, process capability and other related stuff, you could do a lot worse than visit my website at www.gagerandr.com. That's gagerandr.com. I hope this video has been helpful, but if it has or it hasn't, let me know. Thanks.